Hey, welcome back. So we were in the middle of 19. While I was away, I went and looked at 19. This turns into x squared plus 2x. And remember, this turns into 64 right here. And if you subtract it, you end up with minus 64 is greater than 0. Now here's the problem with this problem. Normally these would factor and we could figure out the answers. If you remember way back when we did quadratics, sometimes we had to solve these by graphing the parabola and seeing where it was above or below. I'm going to tell you we're going to stop on this problem because the final answer turns out to be x is greater than 7.06 and or x is less than negative 9.06. But the only way you can get that answer actually is by graphing it on a graphing calculator, and then you get a parabola, and when it's greater than 0, the parabola is probably going to open something like this. And you're going to end up with like this little branch and this little branch, so it's this and this. I don't know if you remember doing those first semester. This problem, we're going to just not worry about it for the test. So you can just ignore number 19. If we did have one like this, it would work out much nicer and you wouldn't have to do all of this stuff, okay? All right, number 23. Now, this one is not one where you could solve it by putting 53 into a power of 2 to some power. So when you can't solve it without a calculator, this is when we're going to log both sides. So we're going to go log, and we're going to get the log of 2x equals the log of 53. Okay? And then we can use our laws of logs, which tells us we can take this and put it out in front. That's one of your properties of logs. And you end up with this is equal to the log of 53. And then you simply divide by the log of 2. And on a calculator, you can figure out the rest of this. So over here, watch this. I will go log of 53, close parentheses, divided by the log of 2, close parentheses, and I get the decimal of 5.7279. Okay, so basically that one's going to be a decimal. It's going to have to be done on a calculator. So remember, if you ever see E, you can ln both sides. If you don't see E, you can log both sides if it's one you can't solve. We're going to use that same trick on these next problems. So watch this. When I get down to here, again, there's no way to solve 24 without a calculator. So what I'm going to do is I'm going to log both sides. Sorry, my handwriting is so bad. I am trying to do this on my lap, and I'm trying to be careful not to bump the screen. So basically, I get the log of 9 to the 3y minus 2. This is such a mess. I'm going to redo this. Sorry, guys. Let me do this one more time. So we're going to log both sides. I'm going to put a log here and a log here. Okay? So on the right, I'll have the log of 11. But on this side, I take that exponent, remember, and I throw it in front. So I get 3y minus 2 times the log of 9. And then I would divide by the log of 9. So I go like this. And I get, I'm going to go up here now, 3y minus 2 equals, and this whole mess here I'm going to do on a calculator. So I'm going to go log of 11. This is what's so hard, guys, is I'm trying to do this with a calculator. Log of 9. And I get the decimal 1.0913. Then I would add 2 to both sides. So taking it down here, I get 3y equals 3.0913, and then I divide by 3 and I'll be done. So I get y equals, if I add 2 to this, and then I divide by 3, I get 1.0304. Usually it's a lot easier to make these videos if I don't have a split screen, but I really need the calculator so you can see what I'm doing. So number 24 turns out to be that. Number 26. Now, on number 26, the real important thing is that whenever you're trying to solve one of these, the first thing you want to do is move the 9 over first. Okay, you cannot ln both sides until you've isolated the e. So I would get 7. Then I would divide by 3. So I get e to the x equals 7 over 3. See how I'm cleaning that up? Now, once I have the e isolated, now I can ln both sides and it will wipe that out. So the ln of e just cancels out and I get x equals the ln of 7 over 3. Now I go to my calculator, ln of 7 divided by 3, that whole unit, and I would get, for the answer to this one, 0.8447, and I'll just round that to 3. So 0.8473 would be the answer to that one. Double checking that a second with my answer key. Yeah, that looks great. Okay, and then finally the very last one, 25, is actually way easier than 26. I should have done 25 first, but this one you just ln both sides. So the ln and the e cancel out and you get x just equals the ln of 5. And so again, grab your calculator and go ln of 5, close parentheses, and I get 1.6094. Okay? That's a 9, by the way. That looks good. All right, so you're kind of following how to do all those. Sorry it's such a mess. I just don't have much room to work on this computer because of the split screen thing I'm working with right now. Okay, so sliding this up to the next few problems here. Oh boy. I don't know why this is doing this, but we're going to make this work. Okay. Now, by the way, on the review, you don't have to worry. On the review, you don't have to worry about the graphing part, so you won't see these graphs. All you'll have to do is tell me if it's growth or decay. So on number 27, this would obviously be decay, because the number right here under the x, which is your b, when you think of your standard form, because b is less than 1. And then this one, of course, this would be growth. And again, if I said y, it would be because b is greater than 1, the number under the exponent. Okay, we are almost done. We just got to finish up these word problems real quick and we should be good. Now, I'm going to run out of room here, so I don't know how I'm going to do all this, but I will probably do the work down below and then I'll just erase it each time. So we'll just kind of do this. So I'll do 29 down here, starting with this first one. In 2004, there were 2 rabbits on the Blasey farm. In 2007, there were 18 rabbits. Now, again, 2004 is where we're starting, so that would be year 0. There was 2 rabbits. And then the next one is 2007, which is 3 years later. So I would do 3 years later, there's 18 rabbits. Whenever you have a word problem like this, you want to convert it into data points. So like 0, 2, and 318. Where x is my time, that's time since 2004, and this is my number of rabbits, okay? So now it says model this equation with an exponential function and determine how many rabbits would be on the farm in 2010. Will there be at least 500 rabbits? So again, what I'm going to do is I'm going to take y equals ab to the x, y equals ab to the x. I'm going to plug these in as points. So this is my x, so I pop that in here. This is my y, so I get 2 equals ab to the 0. That, of course, cancels out and just becomes a 1, so we know a is 2. Then I plug the 2 into here, So I get 2b, and then I plug in 3 for x, and I plug in 18 for y. And again, I'm plugging in this for x and this for y. So I divide by 2. So 9 equals b to the third power. And then to get rid of a third, I would cube root that. So on my calculator, I'm going to go math for cube root of 9. And I get 2.08008. So my function would be y equals 2 parentheses 2.08008 to the x power. Probably don't need to carry it that many decimal places, but I'm just going to leave that for now. Now, that's my equation. Now it says, how many would there be in 2010? Now be careful, because we started with 2004, so you wouldn't plug in 2010, you would plug in how many years later that is, which is 6 years later. So on a calculator, I'm going to go 2.08008 to the 6th power. So on this calculator, I'm going to go 2 times parentheses 2.08008 to the power of 6. And it gives me about 161 rabbits, about actually 162. If I round it up to the nearest rabbit, would there be at least 500 rabbits? The answer to that would be no. Okay? So that's the rabbit problem. The next one is number 30, the Mr. Geertsma problem. So what I'm going to do here real quick, just because I don't have any room on this thing, is I'm going to erase this problem now. We're going to start all over again. I'm just going to use this little area as my workspace. This is kind of the bummer about computer stuff, is you don't have your nice big whiteboard. Okay, so the next one says Mr. Geertsma bought a car 3 years ago for $14,795. Now the car is worth $9,000. If the car depreciated at a steady rate, what was the rate of depreciation? Now, since it depreciates at a steady rate, I know I'm going to use my y equals a 1 minus r to the t formula. Anytime it's a steady rate or per year, if it doesn't say the word continuous growth or mentions the letter k, you're going to use this formula. Okay, so I know the initial value of the car is $14,795 minus 1 minus r. R is what I'm looking for because I want the rate of depreciation. I know 3 years has gone by because it gave me the time was 3. And now the car is worth $9,085. So basically, y is your final value, a is your initial value, t is your time, and r is your rate. So I got to solve this dude. So first of all, what I'm going to do is I am going to divide by 14,795. So on this calculator here, I'm going to go 9,085 divided by 14,795, and I get a whopping 0.614 equals 1 minus r to the third power. Now the next thing I'm going to do is, how do I get rid of a third power? Well, the opposite of taking something to the third power is to cube root it. So I'm going to cube root both sides. So I'm going to go math cube root of second answer, and that will plug in that answer I just found. And I get 0.84996, so well, I'll just leave it there for now, equals 1 minus r, because remember the cube root cancels out the cube. Last thing I got to do is subtract 1, so I'm going to go second answer minus 1, and I get negative